All right. Okay. So let us start. In our in the last class, we have been looking at this slide, the introductory slide. And so far what we have seen is what are the different structures that you can find in any OR model, or you can set the blocks in OR model. And then based on those blocks, we have seen how to identify different model types. Okay. So given a formulation, now we can say when this formulation is linear or integer or nonlinear or integer nonlinear. These are the four major classes, and this is what you'll find typically in any application. So let us quickly revise. What are the three blocks of a mathematical model?
Objective function and constraints and
what's the last?
Restriction domain.
Objective and restriction domain.
We have things related to the objective function, then to the constraints, and then to the restriction on domain. Okay, I could say your constraint functions and objective function if you want to be precise. And then in the last class we did the small matrix to see how different models can be fit here. Okay, we were interested in these models: linear programming. Okay. And then we had integer programming. And when we say integer programming, roughly, by default, it means it is linear integer. Okay, always remember this. And then we have nonlinear programming. And then we had integer nonlinear programming. Okay. So now let us see if we still remember what we have seen in the last class. So what makes a linear program? I would like one of you to tell me what makes a linear program. What should be the thing that you should find in objective function or constraints or restriction on domain?
linear objective function.
Objective function should be linear, that's correct.
Yes.
What about the constraint functions?
All linear.
Yeah, all of them should be linear. Yes, that's correct.
And the restriction domain should be all continuous.
Yeah, should be all continuous. So if this is the thing in your mathematical model, then it is a linear program. And in your 303, if you go back to your 303 notes or slides, you will find that all the models have this. Okay, all the models, they have these properties. Now, what will make it an integer program? And remember, when we say integer, roughly speaking, there is a small L here. It means linear integer program. If it is non-linear, we will highlight it. Okay, but if it's linear, you usually don't highlight it. So, what makes it a linear integer program?
For the objective function is linear, and for the constraints it's all linear, and
Okay.
the discrete the discrete I think it's discrete.
Restriction on the variables, you can say, or restriction on domain. But all of them should be discrete?
No, some of them.
No.
Some.
At least one.
At least one.
Somewhat.
Yeah. Because some of them could be discrete and some of them could be continuous. Sometimes you see that many people, they call IP as MIP, mixed integer program. Of course, it's linear, no doubt, but also to highlight that you could have variables, some of them are discrete, some of them are continuous. It is sometimes called as mixed integer program, MIP. But IP is also fine. Okay. So let me just color this so we remember this one. Okay, how about NLP? what makes a mathematical model nonlinear programming problem? Yes, Amir.
Either nonlinear or linear in the objective function, and some nonlinear constraint, and all should be continuous in restriction domain.
Okay, so you should find nonlinearity either here or here. Okay, anywhere you should find some nonlinearity. So either in the objective function you should have some nonlinear, or some of the constraints should be nonlinear. Okay, either the objective function or some of the constraints should be nonlinear. And then if you talk about restriction of domain, now we are saying that all the variables should be continuous. So that is what makes it a nonlinear program. And looking at these three classes, now we can clearly say what is an integer nonlinear program. So it has both properties of integer and nonlinear, which is either there is some nonlinearity in the objective function, or there are some constraints that are nonlinear, and some of the variables are discrete. So all of them makes it an integer nonlinear program. So this is something that we covered in the last class. This was the main theme that we covered in the last class. In today's class, we are going to have a small quiz, but again, it is just a class activity. It is not the quiz that will be, that will give you grades. It is just for exercise of these topics. Okay. So I will give you a link here, maybe in the MS Teams now. I will send you a link, and then we can work on the quiz together. Okay. So I'm just sharing a link now. Okay.
Doctor,
Yes.
should we submit the homework or quiz, or is it just for us to do and that's it?
Yeah, just for the class. It's a class activity.
Yeah,
There's
okay. So we don't have to submit it after all.
It is online actually. I'm just sending you the link now. Do you see this link, guys?
Yes.
Okay. Just log into that link, and it will ask you for game pin. So here is the game pin.
Doctor, where I can find the link? I cannot see it in the chat of this room.
You cannot see chat. It's in chat box. If you see, there's recording, mic, share screen. Then there are three dots in the same. There is a chat box: hide conversation or show conversation. If you see from the right, where you have this disconnect the meeting call, just two boxes before that. Do you see it? I see now there are 21 players. Let me just share with you how things are here. And then let me. So now 29 players logged in. Okay. 32 players, 33. We have all 50 guys in our class. Anybody facing any issue, all you have to do is go to this link and then type this number. Okay, 40, 10 more. Okay. Also, it might start music. It is something that is not controllable. So you can click on this button to stop music or mute it. Okay? There's no setting for me from the beginning to stop the music. Okay, so 5 more to go. 6 more to go. Okay, I will fix my voice. Maybe I will see here. How about now? Is it clear, Abdullah?
Not yet.
Doctor, I'm facing a problem.
Facing a problem where? Is it clear now?
I think it's clear, but there is a noise on the background. Okay, it's now clear.
Okay, thanks. Okay, yeah. So somebody said that he has a problem. You have problem to log into this system?
Yes, doctor. Also, the link is gone now.
Okay, I think it started. So if the link is .it, and students are doing this. All you have to do is you look at this mathematical model and click whether it's LP, NLP, MIP, or MINP. Okay. The link is straightforward. Kahoot.it, and then say play game, and it asks you a question. Okay. And now you see, oh.
Doctor, we didn't have time to answer, I think.
The question it says time's up.
Yeah, you have to be fast, huh? Look at it and answer it. It gives you 20 seconds to answer. So you just
Doctor,
look
it
at
doesn't show me the question.
Click on this. Okay?
It only shows me square, triangle, and circle. That's it. There's no question.
Me too.
But
Yes,
I can't
There's
see
no
it.
question, doctor.
Me too, doctor.
But you can see the MS Teams screen here.
Guys, the question is in the screen of Microsoft Teams, and the answers you can choose it from the website.
Oh, I see.
Okay. So the question is here, and you see it's LP triangle, NLP diamond, MIP circle, MINLP box.
Why, doctor? Why it's not LP?
Hold on to your questions. I will review it with you after the quiz. Okay. Remember, MIP is same as IP, and INLP is same as MINLP. This R plus means greater than or equal to 0. It is like R, but it's greater than or equal to 0. So we have 3 top scorers, and then these are the results. What's happening now? I think it's trying to restart or something.
I think it is restarting. It will start again.
Yeah. I'll just stop it. You don't have to play. Just stop it. So you see, in this quiz, all I was testing was whether you understood the mathematical model types or not. And here are the results. Let me just see which question you did, most of you did wrong. Okay. There are some students who get any one correct. I think this is something serious. Maybe there was an issue with the system and you cannot log in or you cannot see the questions or something, or maybe you clicked wrong. So if you are, I don't want to show the names here, but if you are among those students who didn't get even one of the questions correct, please, after the class, meet me and I will help you with your doubts or concerns. But let me tell you who scored the highest in the class. Of course, the highest means the right answer and also fast. Okay, 2 things. Time is also important. Okay, so the first highest scorer, let me just show it to you guys. For high scorer, I think you guys will not mind sharing your name. Of course, these are your nicknames, so I don't know exactly who this person is, but you know who you are. Okay, so Abdullah, he got 75% correct answers. That's good. Then Nawaf, then Faisal, then Muhammad. Okay, then very secret names, and it's very hard now. Okay, but you can see the scores. Okay, all right. So that is how you guys performed. Now let us see which question was the most difficult one. Okay, so I'm looking at the one that was answered mostly incorrectly. This was the question. Can you see? Can you see this? It's a bit small, huh? Can you guys hear me?
Yes, yes, we can.
Yes, we can.
Yes, doctor.
So, this is a question that most of you answered, and only 7 of you, I think, answered correctly. This was least correctly answered. So let us see what this question is in our slides. Oh, actually, it's the first one.
Yeah, maybe it's because the first one.
Yeah, it looks like it's the first.
Because the method wasn't obvious.
Okay, because maybe at the beginning, yeah, because it was the first time, most probably, the question was in the MS Teams and on your mobile phones or something. It was just showing you the answers, so that could be the reason. Okay, let us look at the next question. Yeah, I think this one usually I see most of the students answering it.
Doctor, I think this answer is wrong because x1 is times x2, so it is non-linear, right?
Most of the time the students get this wrong.
Yeah, but the answer on the application is linear, so that's why.
5x minus 2 minus 5 exponential.
Yeah, but on the website it said linear, not non-linear. The correct answer, I mean. That's why it's got, many people got it wrong.
We highlight it, okay? So here you have 5 x1 x2 plus 15 x1, right? 15 x1 plus 5 x1 x2. On the other side you have 5 x1 x2. So this will cancel out. Did you get that, Muhammad?
Yeah, I can see it now. I can see it.
Yeah. So sometimes, and I keep this here because sometimes it looks like nonlinear, but then with some analysis simplification, it might turn out to be linear, and there are many such cases. Okay, so that's why I kept this question, and I remember in many classes, many times it happens that the students they miss. Okay. Now let us see the next one. The 16 and this one's 22. This one here. This was the simplest one, but most of you answered this as NLP. It is strange. Yeah. This question, most of you answered NLP, but it is not NLP, right? You see, this is the object function is linear. Okay. The constraint is linear. You have 3 square, but that's constant. Constant itself is linear. And the restriction on domain is continuous. R plus, I said it's greater than or equal to 0. Okay. So this is surprising. Why majority of you thought it's NLP. Okay, so those are the, and there's one more low scoring, 22. Okay, actually for this, most of you didn't answer, so I think this one doesn't qualify as low score. So that's it, and that was a quiz, a small, just to refresh what we have seen. And here are the models. If you have any questions, if you thought something is correct, for example, like this, then yes, you can ask now, or then if not, we'll move further. Okay. Yeah, the time is 20 seconds, and you just look at it and answer. Okay. There is a way to increase the time. I have seen this, but it turns out that I have to increase for every question. So I thought 20 seconds should be good enough for these small problems. But maybe next time we will have maybe slightly 30 seconds or 40 seconds. Again, remember, these are questions. Again, it will not be graded. Sorry, it will not be part of your grade. But it is just like some sort of exercise of what we learned. Okay. So maybe next time I will increase the time to 20 or from 20 to 30 or 40 seconds. Okay. Actually, this is the first time. Last time we tried, but it was too late. So this year or this semester, I tried it for the first time in the class. Okay. So this is one of the issues. Maybe next time I will increase the time. Any other issues that you found with the system, with this Kahoot gaming style system? Any suggestions you have for this? No suggestion?
No, I think it is good to me.
These are the answers for 1, 2, 3, 4, and these are the answers for 5, 6, 7, 8. Okay. Yeah, if you want to have the questions, I think you need. I was trying to look at this, but I know. I think the reason why you cannot have the question is because you want everybody to see the questions at the same time. Okay, but there is another option where you can have different speeds. Okay. Okay, number 5. Yeah, you can use your phone while the MS Teams is on your screen. You can use your phone. All you have is just 4 buttons: the square, triangle, circle, and diamond. So all you have to do is click on those. Yeah. Number 5 says LP. It is IP, integer program. Mujtaba, this is integer program. Why? Because this Z plus, I explained in the last class, right? What is Z plus? Z plus is all the integers starting from 0. Okay. So Z plus is different from R plus. Okay. All right.
Doctor,
Yes.
if we are going to put this model on GAMS or any software optimization software, is it going to identify the type automatically, or I should identify it myself?
You should identify yourself. Yes, that's a very good question. So if you are using a software like GAMS, Ample, Lingo, of course Lingo and Lindo, they are only for linear. But if you are using a software like GAMS or Ample, you have to tell what model it is. If let us say it is a non-linear and you selected the solver for linear, it will throw an error. It says this is not right solver. That's it. But it will not tell you what model it is. It will give you, it will say, oh, the variables have some product or multiplication of variables and things like that. But no, you have to pick the solver according to the model type. And model type, you should have some mechanism to know what model type it is.
Okay, thank you.
Yeah. What is the difference between MINLP and INLP? No, not really a big difference. In general, you can call it as MINLP. Okay. In general, you can call it as MINLP. What M stands for? Mixed. It means some of the variable could be continuous, some of the variables could be discrete. So that's why it is called as mixed. And in general, if you pick any paper or any book, most of the time they call it as MINLP. Although it is INLP, it is called in general as MINLP. Like here, it is IP, but in general, it is always called as MIP. Okay. So even if you have all variables discrete or some discrete, some continuous, it is called as MIP. So MIP, MINLP is a general term. That's why I included here. But if you want to be very precise, you can say, no, INLP means all should be integer, whereas MINLP means some integer and some discrete. Sorry, some continuous and some discrete. Okay. So that's the small difference between MINLP and INLP. Yes, for the first class, I think for all the classes, the recordings are done on Blackboard itself. Okay. I'm not sure. I think in the first class also we did recording. Yes, it is on the Blackboard. Unfortunately, now I think even still the Blackboard is not running. But if you guys are able to log in Blackboard, you will find the recordings for the first class as well as for the second class.
Yes, I can see them now. They are up there.
Yeah. All right. Now another thing to remember, although we are defining different classes with sharp boundaries, that this is different, this is different, but it turns out that sometimes the boundaries are not that sharp. For example, look at these two. On the left hand side, you have a variable x. What does it mean? What type of variable it is?
Binary.
Binary. Okay. Now if you look on the right hand side, you have another variable. So let me just use some coloring here. This is one, let's say, variable, and then this is another one. So if you look only in the information in this green I don't know, whatever, circle or ellipsoid, you will see that there is a variable x. What type of variable it is? Variable x here in the green highlighted region. If you look only at this two, what do you say?
Can be 0 or 1.
Yeah, but what type of variable x is?
Continuous.
It's continuous, right? It's a continuous variable. But if you look in the red region, it is binary variable. But they both act the same. The possible values of x here are 0 or 1. Okay. Here also, what are the possible values of x with this constraint? It is 0 and 1. So you see, here is binary, discrete variable. Here it is continuous variable. So every binary variable can be converted to a nonlinear constraint plus continuous variable. So you see the boundary that says it's a nonlinear, it's linear, it's integer. It's not really that sharp. Yes, Muhammad.
Why we would want to change it into a nonlinear form? Why don't we just write it in a binary form?
It is your choice, and that is what I'm trying to convey. That it's your choice. You can formulate the same scenario as binary, and somebody else can formulate the same scenario as nonlinear.
So there is no other purpose other than preference, maybe, right?
I missed your last. There is no other purpose
except for preference of what.
It's your choice. Yes, it is your choice. Sometimes nonlinear formulation gives you better tool for analysis. Maybe if you have binary formulation, then you have good software packages to solve the problem. So it is your preference, and also what are you trying to do with the model? Okay.
Okay.
Yeah. Go ahead.
Doctor, can you just re-explain how it becomes similar for the binary and nonlinear?
Okay. For the binary, the one in the red region, what are the possible values of x?
0 and 1.
Okay, good. For the green region, let us see what are the possible values of x. Look at this constraint. X times x minus 1 equals to 0. This implies that either x is 0 or 1. Why? Because if you plug in 0 here, the left-hand side will become 0, and it satisfies this equation. If you plug in here 1, it satisfies the equation. So the only possible solution for this equation is x equals to 0 or 1, which is same as what it says here. So by the look, it looks like discrete and continuous, but when you actually look for the feasible solutions, they have the same feasible solutions. 0, 1 here and 0, 1 here. That's why they are the same. Okay, Amir?
Yes, okay. But how about the x greater than 0? We just disregard it?
No, it is intersection. When you write many constraints, when let's say you have constraint 1, let's say 3x plus 4y equals to 7, and then you have x plus, let's say, y greater than or equal to 2. So this constraint and this constraint. So in the OR, when you write so many constraints, it means and. So the first constraint says x equals to 0 and 1. The second constraint says x greater than or equal to 0. When you combine these two, what will you get? So x is 0 or 1 and x is greater than or equal to 0. If you combine these two, the result will be x equals to 0 or 1. It is intersection. Whenever you have many constraints in OR formulation, it means it's an intersection of all of these. Okay. Yes, Ali?
So what's the benefit of it?
No benefit. I was saying that the purpose was to tell you that if you have the same scenario, you could come up with different model types. One could come up with a binary formulation, one could come up with a nonlinear formulation.
I mean x greater than or equal 0.
What is the benefit of that here? Well, and for this particular case, there is no benefit. I could have actually removed it. Okay, I could have actually removed it.
Okay.
It really doesn't, help here much. Any other questions? Okay. Again, this is also something very important to remember. Sometimes you have integer variable, and that integer variable can be converted to binary variables. For example, here you have on the left hand side integer variable, which is x that can take the values 1, 2, and 3. Okay. But on the right hand side, you have group of constraints. Together, they ensure that the value of x here is also 1, 2, or 3. But the good thing here is x is no more an integer variable. In fact, here there is no restriction on x. That is, x could be unrestricted, belongs to R. Okay. But then we have 3 binary variables. So here you have 1 integer variable, on the other side you have 3 binary variables, plus 1 unrestricted variable. Okay. Again, this is a choice of preference. If you have integer variables, it might be very good for theoretical purposes or analysis. But if you are trying to solve it using some computer package, then yes, you can use the integer variables directly, but maybe by converting it to binary, you might get more options, some of the powerful options that you can get from Cplex or Gurobi type of solvers. So again, it's your choice whether to go with the integer formulation or binary formulation, mixed binary, and different advantages can be exploited from different formulation types. Yes, Amir?
Doctor, in case all 3 y's are zeros, so doesn't mean that x should be include 0 also?
Yeah, but you see this constraint is saying that this case cannot happen. Exactly one of the y's should be 1. That's the reason for this constraint. You see this?
Yes, it's clear now.
Okay. Of course, these are some cases that appears maybe frequently in OR, and then you have this another special case that also appears a lot. Sometimes you have 2 binary variables x and y, and you have the product of those 2 binary variables. The product of those 2 binary variables can be easily converted to this linear style constraints. Okay. So here you have xy product, but now there is no product of variable xy. So from nonlinear binary, you are moving to linear binary. This is a very powerful trick, and these two may be not that common. And if you look from top to bottom, this one is very common. This is one of the common tricks that we use in formulation. Then this one bit rare. This one is very rare. We never very rarely we use this. Okay? But this is something very common. And try to remember this. And if you're doing your senior design, which involves such formulation with binary variables, you might have such product of binary variables. Then immediately you can replace that by such transformation, and it will become linear. And linear is much better to handle, and for the analysis purposes and also for solving using computer packages. Okay.
Doctor. So these are all restrictions, not constraints, right?
Constraints also, here you have these constraints, right?
These are constraints?
Yeah, these are constraints, and that's the restriction. Okay. Restriction, constraint, what's the difference? Constraint is a generic word. Restriction, when we say, it means for a single variable. So these are the restrictions, and these are the constraints.
Okay.
Khaled, you have a question?
Yes, doctor. So it can be non-linear and linear at the same time, right?
Yes, you could have a model. It could be non-linear, and you do something, and it becomes linear. Not all the models. Okay, I'm not saying in general this is true, but there are some cases like here. Here on the left-hand side, if you look at this model, it's non-linear, but on the right-hand side, it's linear. So you could have some cases where you can have different formulations for the same scenario. Okay. So as a rule of thumb, or some like a guideline, all the linear programming and network pro models, they are very easy to solve. So in 303, the models that you have seen are very easy to solve. In general, the integer and mixed integer problems, they are not easy to solve. They will take time. Of course, now we have powerful computers and softwares, but in general, they are difficult to solve. For NLP, we cannot say, like a general rule. All you have to remember is there are some easy NLPs to solve, and then there are some difficult ones. The easy ones and difficult ones, we give them a name, convex, concave, and these ones we are going to learn about in our last chapter. So just remember that there's easy NLP and difficult NLP, but what is easy, what is difficult, we'll see in the last in the last chapter. Okay. Now it's like a summary, something that, and of course MINLP, they are very difficult. Okay. In general, MINLP are difficult ones to solve. So whenever you have a formulation and you have MINLP, try always to convert it to IP or MIP using these tricks. Using this. As a rule of thumb, you can say that whenever you have convex problems, and what is convex problem? Just hold on to that word. We'll see in nonlinear programming class. So whenever you have convex problems, they are easy to solve. Whenever you have non-convex problems, they are very difficult to solve. So this is all what we have in the first slide. Just 1 minute and I'll stop here. The first chapter, or first main topic will be on mathematical modeling. Then we will have special, and not all mathematical model types. We are going to focus on integer programming mathematical models. And then once you are done with the modeling, then we see how to solve them. We are going to see exact methods, which is in this slide of integer programming. And then we are going to see heuristic methods, which is a slide by itself called heuristic methods. And then we will see another class of mathematical modeling, which is nonlinear programming. And for that, we will see exact methods in our course. If we have time, very rarely we have time, but let's say if we have time, we will also see heuristic methods to solve the nonlinear programs. And that is how the topics of the course is designed. All the things are connected. And once you finish this course with your 303 and 321, you have very good understanding of OR, deterministic OR problems. Okay. So we'll stop here. If you have any questions, any comments, let me know. I'm on MS Teams, and we will we can talk on MS Teams. Apart from that, for the office hours, I will send a link soon on the Blackboard or maybe MS Teams, depending on what is the good channel. And I will take a small survey from you guys, and then based on the survey, I will have the office hours from the next week onwards. Okay, that's it. So if you have any questions, any comments, you can stay. Otherwise, you can leave. Okay, I think I have a question now. Just a second.